Good morning students, this is Joy Varghese from Uncovering Chemistry. Today in video 8 we are going to discuss about finding oxidation number of polyatomic ion, right? Till now we have seen all simple neutral compounds what we saw, but now the charge means charge will be written on the compound, that's why it is called polyatomic ions. So that we are going to discuss now. Okay, now if you seen that the first one what is given, example I will give. Now this you can write down as an extra question. That is first one. I think you can see that ClO3 minus. Now in this you have to find of chlorine. Okay, Cl you have to find the oxidation number. Now in this this we will take it as X and this we will take it as minus 2. Understood? So X plus 3 into minus 2, sorry, just a minute. ClO3 minus 1 is the charge. Okay, on this is a polyatomic ion. Oxygen I will take minus 2 into 3, which is equal to, first in the beginning what we did, no, we were writing here 0. But when we talk about the charge compound, no, here minus 1, whichever will be the charge will be written here instead of 0. Okay, so here X minus 6 is equal to minus 1. So X is equal to minus 1 plus 6. So X is equal to plus 5. Understood? So therefore, oxidation number of Cl in ClO3 minus is plus 5. Understood? Now you will be thinking that chlorine is electronegative, then why it is what you call it as plus 5? The reason is oxygen is more electronegative than chlorine. Understood? Because in Pauling scale we have discussed that oxygen Pauling scale. Clear? We have discussed that oxygen electronegativity, it is in the Pauling scale is 3.5. And chlorine, when we say no, chlorine, it is 3.0. So oxygen will have negative oxidation number and this will have positive. Whenever more electronegative are there, no, both are non-metals, but here oxygen is more electronegative than chlorine. Understood? That's why chlorine oxidation number is plus 5. Okay. Now the next. Okay. Next one example what we say it is CrO4 2 minus. CrO4 2 minus. So in this case you have to find of chromium. Okay, so we will take this as X. So X plus this oxygen will be minus 2. So 4 into minus 2 and the charge what we say is minus 2. So I will write here after the equal to sign. So X plus X minus 8 minus 2. X is equal to minus 2 plus 8. X is equal to plus 6. Okay, therefore oxidation number of chromium in CrO4 2 minus is plus 6. Understood? So this was about chromium. Same way there are many other things, many other techniques and other questions are there which we will go through it one by one. Another one is VO2 plus. Third example, VO2 plus. Now in this we have to find out vanadium. So vanadium I will take it as X, this will be minus 2 and plus means plus 1 is the charge. So X plus 2 into minus 2 is equal to plus 1, X minus 4 is equal to plus 1, X is equal to plus 1 plus 4, X is equal to plus 5. So vanadium, vanadium oxidation number is plus 5. Okay, so these are all what you call, other are also there, polyatomic ions. You must have heard about PO4 3 minus is there, CO3 is also there, many are there. So you can also find by yourself also to do this. Now this one you can write it down as an example. Now specific typical substances are there, that also we will discuss in this video. Okay, it is given in your textbook. So that I am going to discuss. I'll rub this. specific typical substances. Clear? Now in this case, specific typical substances, when we say, no, one example is there in your textbook, it is given. You can see it is H2SO5. H2SO5. This one is very important because it is asked in entrance, our board also. It is called Carose acid. Which acid? Carose acid it is called. And the actual name, when we say, this is a common or tribal name, what we say, it will come later on. Per-monosulfuric acid. What is its name? Per-monosulfuric acid. Clear? Now, when we say in this, we have to find out sulfur. Clear? But when we directly find, no, like this, if you put it x here, +1 and -2, what it will be? 2 into +1 plus x plus 5 into -2 is equal to 0. So 2 plus x minus 10 is equal to 0. X minus 8 is equal to 0. X is equal to +8, what we say. Understood? But actually this one, traditional our method is x means what? Sulfur you get, sulfur is equal to +8. It is wrong. Understood? So that we are going to find. Now in this case, no, you have to see the structure. When we say the structure, it is the structure of this is HOS double bond O dash O dash O dash S dash H. Now I think it is sorry, one sulfur is only there. So like this. Now when we say, no, this oxygen, when it is nearer to each other, actually it is peroxide. What it is? Peroxide. And we have seen in the exception that when we talk about peroxide, oxygen will have -1 oxidation state. Understood? The remaining oxygen, what we already took according default, that is -2, -2, -2. Sulfur we have to find, so we will take it as X, what we say. Hydrogen +1 and +1. Understood this part? So when we talk about hydrogen, write with black pen, +1, +1. Okay? Remaining sulfur will write X it is, so black only I take. Okay, so now when you calculate, there are 2 hydrogen. So 2 hydrogens are there. So what I will write here? I will write here 2 into +1. Now this is for what? Hydrogen. Now I will take here sulfur. I will take sulfur. I will take not sulfur. I will take oxygen. Clear? These 3 oxygens I will take. Now in this 3 oxygen, 3 into -2 it is. That is oxygen which are double bonded with each other. What we call. Here you can see with sulfur and with hydrogen and sulfur. So -2 plus sulfur. I will take X here. This is for sulfur. This was for oxygen. Understood? But now for peroxide form of oxygen, there are 2 oxygen and -1 charge we have to take. So I will take 2 into -1. That is O dash O, what we say, no, peroxide. Okay? So this only you come to know by the structure, if you know. Clear? And this you will be studying in what you call it as chapter 4. Okay? Chemical bonding and molecular structure. So -2 is equal to 0. So now if you find out, it is 2 minus 6 plus x minus 2 is equal to 0. This -2 get cancelled. X minus 6 is equal to 0. So x is equal to +6. Understood? So we can write, therefore oxidation number of sulfur in H2SO5 is +6, and this is the correct oxidation number. Directly with our traditional method we got +8, so that's why it is wrong. Understood? So there are typical 3 examples are there. Out of this is one. You can write down in your fair book. Now the next one I will write. Okay, next one, that is per disulfuric acid that I am going to do. I will rub this. Now second one, when we say it is H2S2O, H2S2O, O8, O8. This is Marshall's acid. Clear? First one what we discussed was Caros acid. This is Marshall's acid. Okay, they will ask what is the formula of Marshall's acid in 1 mark question. So it is there, you can write down the name formula, sorry. Now the real name what we say according to IUPAC nomenclature, it is per disulfuric acid. What is the word? Per disulfuric acid. Now in this also you must know the formula what we say, the structure. Okay. So when you draw the structure of this, it will be like this. O dash, what we call it as S, one mistake is there. Proper, no? It is 1, 2, 3, 4. 1, 2, 3, 4, H2 and S2. Okay, it is proper. Okay. Now in this case, when we say we have to find out sulfur. So sulfur we will take X. But there are 2X. So we will take it as 2X in this. Okay. Oxygen I already explained you in the previous section. Here traditionally what we do, that I will write for -2, -2, -2, -2. Here this is peroxide. This is peroxide. So -1, -1 for what? Peroxide. Okay. H2O2 what we said. That was there in okay. This one +1 and this one +1. Okay. So first I will write for hydrogen. Just a minute. Okay. So first we will write for hydrogen. So 2 into +1. This is for hydrogen. Then I will write for oxygen. These are -2. So total 6 are there. So 6 into -2. Then I will write for sulfur. 2 are there. So 2x. Then peroxide oxygen I will write. That is what 2 into -1 is equal to 0. Okay. So in this case also 2 -12 plus 2x -2 is equal to 0. So this will get cancelled. 2x is equal to +12, x is equal to +12 by 2, x is equal to +6, right? So we can write, therefore oxidation number of sulfur is +6. Okay, understood this part? Now the next one, the last example, that is chromium pentoxide. Okay. Now when we talk about chromium pentoxide, third example, CrO5. Here you have to find out for chromium. But in this you have to write the structure according to chemical bonding method. Okay. So chromium pentoxide, when I write, it will be like this. CrO, O, and here double bond O. Understood? Now in this case, when we say, okay, just a minute. Okay, it will do, no problem. Okay, so in this case, when we say cyclic oxygen, these are cyclic oxygen, or we can also write it as peroxide. So this all will be -1. Okay, then this one chromium will be X, and this oxygen, what we say on the top, will be -2. Okay, this one. Okay, now when we write this, now if I want to write here, what I will do, I will take for chromium, I will take as X. This is for chromium, plus oxygen, which is in form of this cyclic structure. it is -1. So 4 into -1, that is for cyclic oxygen. Okay, understood? So this one I am talking about, this one. Okay, cyclic oxygen. Then this oxygen, that is 1 into -2 will be equal to 0. So x minus 4 minus 2 is equal to 0. X is equal to -6. Understood? So therefore x is equal to, so not my x minus 6 is equal to 0. X is equal to +6. Therefore chromium oxidation number is +6. Understood? So these are all exceptional cases. Other are also there, but we in your textbook and all it is given this much only. So we will stop here of polyatomic ion and typical substances. Next time from the equation we will be finding out what we call oxidation number. That is what is oxidized, what is reduced and all that I will be doing in the next video. Okay, thank you very much. This I will just rub it. Okay, so in the next video there are certain questions from your textbook that we will do, or you can do second one, you can try question 2 in your exercise if you want, or I will just do it here on board. Okay, next video, 9th video, we will be discussing about what we call it as how to first of all we know to assign oxidation number. So from that we will find out which element is oxidized and which is reduced, which one can act as an oxidizing agent and which one can act as a reducing agent. That we will be discussing in our next video. Okay, thank you very much.